This is our AB Calculus 4 weeks final for the year 2016. This is actually going to be just part one of our final that we took earlier today. And there are 16 problems, most of which are kind of the caliber of what I'd call multiple choice type AP test problems, but I didn't make any of them multiple choice. Anyway, first problem, let R be the region bounded by the graphs of y equals square root of x and y equals x over 2, as shown in the figure above. Find the area of R. And so you're looking for this area enclosed by this red curve on top and this blue line on the bottom between x equals 0 and x equals 4. And what we're going to do is take advantage of an understanding that in order to find this area between these two curves, it's going to be this area here, this red area above the x-axis here, from 0 to 4, minus the area below. I'm putting in green here. And so what you have left, after you take this purple area minus the green area, what you have is what's remaining. And so the setup is going to be like this. That's going to be the integral from x equals 0 to x equals 4 of, we take the top function, which is square root of x, minus the bottom function, which is x over 2, and it's going to be dx. And what we're going to do, I'm going to bring this up here, leave a little more room. We're going to rewrite this in what I call calculus-friendly form. We're going to say 0 to 4, and a square root of x is going to be x to the 1/2 power minus x over 2 and dx. And integrating, what that is going to be equal to is x to the 3/2 power, because 1/2 plus 1 is 3/2. And we're going to divide by 3/2, which is the same as multiplying by 2/3. So out front here, I'm going to multiply by the fraction 2 over 3. And then we have this x over 2 becomes x squared, it's minus x squared, and we have x squared over 2, and then we divide by 2 what we raise the power to, so that's what we have here, and that's going to be from 0 to 4. And then what we have here is 2/3 x to the 3/2 power minus x squared over 16. And we evaluate this from x equals 0 to x equals 4, the limits of integration. Well, this x to the 3/2 is going to be, I'm just going to put 2/3 here, and x to the 3/2 is the square root of, this time I'm going to put in 4, square root of 4, and we're going to cube that. Okay, this is x to the 3/2 minus, we're going to have 4 squared over, well, I said 16 down here. That is wrong, wrong, wrong. It's supposed to be 2 times 2 is 4. So you have x squared over 4. There we go. So we have 4 squared over 4. And that's going to be equal to, and then minus the 0 times all this, which is just going to be minus 0, right? So what we have left is 2 times, what is the square root of 4? 2. Well, 2 cubed is 8, so we have 2 times 8 over 3. And then we have minus 4, because 4 squared over 4 is 4, and that's going to be equal to 16 thirds minus, how many thirds do we have in 4? 12 thirds. So our answer to this is going to be 4 over 3, 4 thirds. So that's where we end up. The problem shouldn't have been that hard. Just takes advantage of the simple integration and the concept of knowing that we subtract one area from the other to get what we need. Next problem we're going to look at is 2. Determine the integral from 0 to 2 of 2x times quantity x squared plus 3. Now, I kind of intended for this one to be a u substitution problem, but it sort of fails in that regard, in that we can simply distribute like this. And so what we have is, we have 0 to 2, and for this we get 2x times x squared. Well, that's going to be 2x cubed. And then we have this 3 times 2x, so that's going to be plus 6x, and that's going to be dx. And coming down, what we have integrating, we're going to have 2x to the, and 3 plus 1 is 4, and we're going to divide by what we raised the power to, so dividing by 4, plus we have 6x squared, and we raise to the second power, we divide by 2. And we're evaluating this all the way from our limits of integration 0 to 2. And continuing to work below, we have 1/2 x to the 4th plus 3x squared from 0 to 2, and that's going to be equal to, we have 1/2 of 2 to the 4th power plus 3 times, that's going to be 2 squared, and we're going to subtract out to the 0. Well, that's the 0 entered for us, so that's 0. So 2 to the 4th power is going to be 16, right? Because 2 cubed is 8. So 1/2 of 16 is 8. So we have 8, and 2 times 2 squared, well, 2 squared is 4. So we have 8 plus 12. So our answer here is going to be 20. Okay, so that is our answer. And this one should have been too hard. Next, if f of x equals 3x to the negative 3rd power plus 1/2 x squared minus 3x, then f prime of 3 equals. So for this one, to find prime, we need to differentiate, and we already have this in calculus-friendly form, so I'm going to rewrite this function just differentiating. We'll have f prime of x is equal to, we multiply by this negative 3, so we take negative 3, and that's going to be times 3 that we have here, and we're going to have x, and this x to the negative 3, we add 1 to negative 3, we get negative 2. And then we have plus, well, 1/2, and we take times 2, because this squared here will multiply by 2, and it's going to be x, and x to the 1st power, and then that's going to be minus 3. So f prime of x is equal to, simplifying, this negative 3 times 3 on top is going to be negative 9 on top, and the bottom we have x squared, and then this 1/2 of 2 cancel each other, so we have plus x minus 3. And then we're going to say f prime of 3. Well, we're going to have think I made a mistake here, didn't I? This one right here, we need to drop the power instead of add. This thing right here should have been negative fourth power, right? Which means this thing down here is going to be negative 9 over x to the fourth power. Okay, so f prime of 3 equals negative 9 over 3 to the fourth power plus 3 minus 3. And this 3 minus 3, they cancel each other, equals 0. So what we have here is f prime of 3 is equal to negative 9 over, well, we're going to have 3 to the fourth power, so that's going to be 81, which is going to be equal to negative 1/9. So that's our answer to problem number 3. Problem number 4, we have d dx, which is derivative with respect to x of cosine cubed x squared. And I'm going to rewrite this as d dx, and I'm going to put cosine x squared, excuse me, and then we're going to cube on the outside because this cosine cubed means exactly that. And so taking the derivative is we multiply by 3, so we have 3 out front, and then we just continue to bring this cosine of x squared, and then we have this 3 minus 1, so we square that. And now we take the derivative of the inside. Well, the derivative of cosine is going to be, I'll say, negative sine of x squared. But wait, there's one more thing, because now we have to take also the derivative of the inside of the argument, which is x squared. So we're going to have to multiply again by 2x. And so multiplying out everything we have accumulated here, we have 3 times 2x times this negative here. So we're going to have negative 6x out front, and then we're going to have cosine x squared, and then we are squaring that. And what we're going to do is I'm going to rewrite that as cosine squared, we'll call this x squared, times sine x squared. And we have the negative sign out front. So this is what problem 4 looks like. Let's look at problem 5 now. What is the integral of sine 2x dx? Well, I kind of have a sense from having worked with integration for a while what this is going to be, but to make sure I get it right, we're going to take this argument and make a u substitution out of this. So I'm going to say let this argument here, 2x, equal u. And so then we'll have 2x dx is equal to u, and dividing by 2, not 2x dx, it's just 2 dx. 2 dx is equal to u. There we go. And so dx is equal to u over 2. And now substituting in this function here, we're going to have this u over 2. Well, I'm going to make that over 2 1/2. And we're going to have sine of u. And du out front. So this substitutes everything we had. Now, when you look at antiderivative, okay, well, the derivative of what gives you sine u? Well, it's going to be negative cosine. So our answer is going to be negative 1/2 cosine u, and then that's going to be plus c, the constant of integration. And just working backwards, if we take the derivative of negative cosine u, we should get sine, which we do. So that's going to work out. And then finally, rewriting with the original argument, we have negative 1/2 cosine, and then we're going to replace that u with 2x and plus c. So that's problem number 5. Problem number 6, what is the limit as x approaches infinity of x to the 5th power over e to the 2x? Well, what happens is you have a polynomial function, and it's x to the 5th power, so the thing is going to get really huge like this, but it's going to be over e to the 2x. Well, e to the 2x is exponential growth like this. So as we get closer to infinity, the bottom function increasing is going to overpower the top polynomial function. So what we have is a bigger on bottom situation. So our answer to this question is 0. Well, that should be pretty simple. Okay, problem 7. A function g has a first derivative given by g prime of x equals quantity x minus 1 times x times quantity x plus 2 squared. And so we're going to look at our critical numbers, and we have to remind ourselves that this is not the original function. Sometimes you look at these and you want to go ahead and differentiate and figure something out. Well, you're given the function in the condition you need to evaluate right now. And so we're going to find our critical numbers. If we set each of these terms, like x minus 1 equals 0, our zeros to this equation here are going to be, our function will be x equals 1, x equals 0, and solving this quantity x plus 2, setting that equals 0, we have x equals negative 2. Now I try to tell my students that number lines are their friends, and this is not an exception here. If we draw a little number line here, and we have negative 2 is our first critical number we'll look at, and then we'll have 0, and then finally 1. And we're going to put g prime on top of the number line and g on the bottom. So what we're going to do is look at a number less than negative 2. Well, if we take, say, negative 3, well, then this x negative 3 minus 1 is negative. This x is negative 3. We have a negative times a negative. And a negative or positive doesn't matter in here, this x plus 2. This x plus 20x plus 2 squared is always going to be positive. So what we have is a negative times a negative, so we have a positive here. And so the function is increasing. The function g is increasing. And then if we go between negative 2 and 0, well, what's going to happen? We have the same situation. We have a negative times a negative, and even at x equals, if we have x equals negative 1, well, we'll make this 20x plus 2 positive, but a positive times a positive is again a positive. So we are still increasing between x equals 0, x equals negative 2, and x equals 0. And now we get to x equals 0. We get past it. We say 1/2 in there. Well, if we choose 1/2, 1/2 minus 1 is negative, 1/2 is positive. A negative times a positive is negative. And so the function is decreasing between x equals 0 and x equals 1. And finally, a number bigger than 1, say 2, well, we'll have a positive times a positive times a positive. And so there we have it. At what values of x does g have a relative minimum? Well, I'll say relative minimum at x equals 1. Why? Because I said f, I'm going to put g. Because g prime of x changes from negative to positive at x equals 1. So that should have been pretty easy. Next problem to look at is 8. Let f be the function f of x equals 4 to the power of x. Estimate for the integral from 0 to 2 of f of x dx using a right Riemann sum with 4 equal subintervals. And so what we have is the interval. We have this, we'll say this closed interval here from 0 to 2. And we want to have 4 subintervals. We got to take this b minus a, so we're going to have 2 divided by 4. So our interval size for evaluation purposes is going to be 1/2. And so now to create a table of what this is going to look like, I'm going to have up above here x, and then below f of x. And for 0, if we plug in 0 for this function 4 to the power of 0, well, that's going to be an output of 1. Next, we have 1/2. Okay, that's going to be like square root of 4 to the 1/2 power. So that's going to give us 2. Next, using the rectangle size of 1/2, we're going to have x equals 1. Well, 4 to the first power is 4. Next, we have 1 and 1/2, or 3 over 2. And that's going to be like the square root of 4, but cubed. So what is the square root of 4? 2, and 2 cubed is 8. And finally, at x equals 2, we have 4 squared, which is 16. And so right Riemann sum, so we will say estimate of 0 to 2 f of x dx is equal to, we can just make 4, we have 4 equal subintervals, right? So I'll just put the blank spaces separated, 4 blank spaces separated by 3 plus signs. Okay, and we know that our rectangle width is going to be 1/2 for each of these. I'm just going to put 1/2 out front here, 1/2, and 1/2. And it says right Riemann sum, so that's going to be, we take this interval from 0 to 1/2. Well, the right side is going to be 2. So we're going to put 2 here. For the next interval, the right side of that's going to be 4. And then we have 8. And finally, we have 16. And the mathematics aren't that hard. We could add these up. We'd have 1 plus 2 plus 4 plus 8 is what this would be. So, but we just can leave it in this form, at least in the free response, and that's fine. Next problem, we have d dx of x minus 2 over x squared plus 1. Now this is a quotient. You have a derivative of a quotient of 2 functions. And so we could make this a product. We could take this quantity x plus 1 to the negative 1 power. But I think this is an opportunity to just use this. We have the high side of this is going to be x minus 2, and the derivative of the high is equal to the derivative of x minus 2, which is 1. And the low is equal to x squared plus 1, and the derivative of the low is equal to 2x. The derivative of x squared plus 1 is 2x. And so now to differentiate and simplify, that's all we need, right? Well, we have low d high. Well, low is going to be this quantity x squared plus 1. Low d high, well, d high is 1, minus high, well, high is x minus 2, minus high d low, and what is d low? 2x. And what is that going to be over? That's going to be over quantity x over low squared. Quantity x squared plus 1 squared. Now, just simplifying, we're just going to distribute this 1, so we're going to get, in the numerator here, x squared, and then 1 times 1 is going to be plus 1, and then we're going to have this minus 2x times x, so that's going to be minus 2x squared, and finally, we're going to have minus negative 2 times 2x, so that's going to be plus 4x, and that's still going to be over quantity x squared plus 1 squared. And the simplification, the final simplification, we have x squared minus 2x squared. Well, that's going to be negative x squared. And then we have plus 4x. That's the only x term we have. And then the last thing we have is 1. So plus 1. And it's going to be all over this quantity x squared plus 1 squared. So that is our answer to problem number 9. Next problem we'll look at is 10. For the function h of x equals 2 square root of x, what is the average rate of change on the closed interval from 0 to 4? Well, does the function exist from 0 to 4? Well, yeah, because we can plug in 0. And in fact, we'll say f of 0 is equal to 2 times the square root of 0, so that's going to be 0. And we're going to have f of 4. If we plug in 4, we're going to get 2 times square root of 2. And square root of 2 is 2, so we are going to get 4. Now, average rate of change, I'll put average ROC, for average rate of change, is equal to f of b minus f of a over b minus a. Well, from b minus a. Well, this 4 is the b, and this 0 is the a. And so what that's going to be equal to is f of b is going to be 4 minus f of a, which is 0, and over b minus a, which is also 4 minus 0. So we're going to get 4 over 4, which equals 1. So that is going to be our average rate of change from x equals 0 to x equals 4 in this function. And in problem 11, for the function h of x equals 2 square root of x over closed interval 0 to 4, what is the value of x that justifies the conclusion of the mean value theorem? Well, the mean value theorem says that if a function is continuous and differentiable over an interval, there exists an instantaneous rate of change that equals the average rate of change over the same interval. So I would just abbreviate this as I rock equals a rock. Okay. And we just look at this function. This function is going to be defined from x equals 0 to x equals 4. Differentiable, we know it's going to be a smooth curve. We saw in problem 1, I think the square root of x is going to be very similar, but steeper. And so, but a rock, okay, one of the students asked me, from problem 10, a rock is equal to what? A rock is equal to 1. So these problems are really related, 10 and 11. And so we're going to differentiate h of x, and h of x is going to be equal to 2x to the power of 1/2. That's what square root is. So what we're going to have is h prime of x is equal to, we multiply this 1/2 out front, so we have 1/2 times 2, and we're going to have x to the negative 1/2. So h prime of x is equal to, we have 2 over 2 cancel, and so we have x to the negative 1/2, so we have 1 over square root of x. And then going to the right here, which I arrow over, we set a rock equal to h prime of x, so we'll say 1 equals 1 over square root of x. Well, if we cross multiply by square root of x, we have square root of x is equal to 1. And squaring both sides of this equation, we have x is equal to 1. So that's going to be the value of x that justifies the conclusion, or satisfies, I think I meant to put satisfies the conclusion, of the mean value theorem. So x equals 1. That's it. That's where I rock equals a rock. Instantaneous rate of change equals average rate of change. Problem 12. What is the equation of the tangent line to the graph of the function f of x equals x cubed, where x equals 4? This should be pretty straightforward. To find a line, we need two things. We need a point. And to find that point, well, we know that the x value is going to be 4. And we need to find f of 4. I come over to the right here. F of 4 is equal to 4 to the power of 3. And 4 times 4 times 4 is 64. So that's our point, 4 comma 64. The next thing we need is a slope. And we will call this slope m sub t. Okay, m sub t, what is that going to be? Well, if we find f prime of x, that's going to be the derivative of x cubed, which is going to be 3x squared. And now if we plug in 4, f prime of 4 is equal to 3 times 4 squared. Well, 4 squared is 16. 3 times 16 is 48. So we say m sub t equals 48. So therefore, writing our equation, we have y, I'll write this, y minus y1, which is 64, equals m sub t, which is 48, and 48 times x minus x1, which is 4. So that's going to be it. That's our answer here in purple below. Next problem. 13. What is the integral from 0 to 3 of the square root of x squared minus 9 dx? Well, this function is not, from what I've heard, integrable, but if you understand what the function is, this is just a geometry problem. The standard form, or general form of equation of circle is simply this: x squared plus y squared equals r squared. And in this case, if we say x squared plus y squared equals 9. In this case, what would r be? If we have 9 in the place of r squared, well, that would be for r radius equals 3. And if we solve for y, we will get y squared equals 9 minus x squared. And if we take the square root of both sides, we have y is equal to square root of quantity 9 minus x squared, but we have to go plus or minus here. But this is really the function of a circle, rather the top half of the circle. So what we're looking at here is a circle with radius of 3 right here. Okay, this is their circle. And this function itself is a half circle. So I'm just going to make this half circle like this. Right, there it is. There's our half circle. But we're going from 0 to 3, and so we're just trying to find this shaded area here. I'm shading in red, which is a quarter of a circle. So our area is going to be equal to pi times r squared, which is 3. Let me just put the generic formula first. A equals pi r squared. In this case, we have a quarter circle over 4, and so we have pi times 3 squared over 4, which equals 9 pi over 4, which is our answer. So really need to be familiar with geometric shapes, and it really could be pretty easy. Next, what is the integral from -2 to 2 of 2x dx? Well, again, this is a recognizable function problem. Okay, if you have this function here, y equals x, and draw on this blue diagonal line, y equals x, right? Well, this function is y equals 2x, so I'm going to draw y equals 2x, which is a steeper line like this, with a slope of 2, so something like this. And what we have is a line. We call this an odd function. The line crosses the origin, and we're evaluating from x equals -2 to 2. And so we look at areas here from -2 to 2. We have a negative area between -2 and 0, and we have a positive area between 0 and 2. And so I would call this a problem where we have a recognizable function. Now, you can go ahead and work this out and find the same answer, but our answer to this is going to be 0. Okay? Recognizable function, areas cancel. To equal 0. Okay, next, 15. What is the integral from 0 to pi over 2 cosine x dx? Well, the antiderivative of cosine is going to be sine. So we're going to rewrite this as sine x, and evaluating from 0 to pi over 2. And we're going to work backwards to make sure we did it right. It's easy to get a sign error. If we take the derivative of sine x, well, that's going to be positive cosine x. I do this Santa Claus snow cone thing where you're deriving down with the derivative of sine is cosine, and the antiderivative of cosine is sine. So if sine stays positive, so what we have is the sine of pi over 2 minus the sine of 0. Well, pi over 2, if we remember our unit circle, pi over 2 is going to be equivalent to, in degree measure, 90 degrees. So pi over 2 is right up here. And in a unit circle, the sine is the y value, so that is going to be 1. Our answer is 1 minus 0, which equals 1. So that is our answer to problem 15. Problem 16, I think this is the last one from this section. What is the limit as x approaches 3 of x squared minus 9 over x squared plus x minus 12? So if we substitute in 0, let's say, not 0, but 3, right? So if we say, just try this out, we're going to have 3 squared in the place of x squared, right, minus 9, and in the denominator we have 3 squared plus 3 minus 12. Well, what that's going to be equal to is 3 squared minus 9, well, that's 9 minus 9, and so that's going to end up being 0. And then 3 squared plus 3, well, that's going to be 9 plus 3, that's 12 minus 12. So we have 9 minus 9 over 12 minus 12. Well, that equals 0 over 0. And I like to tell my students that when you find this, what this stands for is more work. And what we're going to do is factor. And so to factor, we're going to we can take this x squared minus 9 and rewrite that as x plus 3 over quantity x minus 3. And the denominator we can rewrite as quantity x plus 4 over quantity x minus 3. Well, what's going to happen here? We have quantity x minus 3 divided by quantity x minus 3 cancel. So now we can substitute in 3, and so this is going to be equal to 3 plus 3 in the numerator over 3 plus 4 in the denominator, and so our answer to our limit here is going to be 6 over 7. So anyway, those are all the problems from part 1. Good luck. I hope you've learned from this. I tried to make the mathematics on these problems simple enough that they were pretty doable without a calculator. Good luck. Thanks for viewing.